Okay, welcome to this sessions of Simple Pod. In these sessions, we will just try to understand what is the Simple Pod is all about and how to create this pod using the definition file also and using the imperative way by using running the some commands also. So you can consider this as an important part of the CKA exam, and they will definitely ask you at least one questions that will be related with the simple pod. Either they will ask you to create a pod in a particular namespace, or you can be asked in the exam questions like how to create a pod or create a pod for a particular node. So just watch these sessions to have a clear understanding on the simple pod creations. So in these sessions, we are going to cover about what is the pod and why we require to create a pod, how to schedule a pod. So you can schedule it in your own way by defining the node selector. That will come in the selector section when I provide you a session on it, and which component is responsible for it. So you can see that when the pod which don't have the node selector defined in the pod definitions file, so that is the main things that kube scheduler will looking for. If the pod definition don't have the node name assigned in the definitions file, so kube scheduler will schedule that pod in a respective nodes as per the availability of the resource space. So you can say that the pod is the very smallest instance of the Kubernetes, but one of the important things, because inside the pod only your applications is running. Kubernetes is a orchestrations tool which manages the pod, but the pod itself have the applications which is running in the environments. So your pod is a smallest objects that you can create in Kubernetes. Pod usually have one-to-one relationship with the containers running your application to scale up. Okay, so inside a pod you should have only one container of the same kind. Means you can't deploy, or this is not a recommended approach that you put a duplicate applications of the same kind in a single pod. There is a provision that okay, if you require a second container that will be of different kind, that will be of as a helper container. So you can create a new pod to scale down. You can delete the existing pod, but these all things you have to do manually. If any disaster happened and some of the pods get down, then you have to manually bring it up. So this is some, you can say there is some restrictions if your application is running only on the pod level. You don't have the replica sets which handle the desired number of pods. So in these sections we are going only to discuss about the pods, that how to create the pod and how we can manually schedule it, and if something is required that you need to be get scheduled by the scheduler itself, then you don't need to define the node name there. So it is not recommended and also not a good practice to have a multiple container of the same kind as a part of the single pod that I already mentioned. You can have the multiple container, but the other container will be a helper container which is helping the main container, and that will be of a different kind of particular pod. A node can have a multiple pod as per the requirement. So it's depend upon the resource availability the node have. If the node is bigger in size, you can deploy a multiple pod, and this is good actually for the load balancing prospects that you want the if you deploy the pod through the replica set, or the most important thing is the deployment, which have the advanced feature that we'll discuss in the next session. So basically, it's a kind it can do a load balancing also. So you can deploy a node in a different node pod. You can deploy a pod in a different node to manage your resources as well. So each worker node is managed by the master node through the kubelet. Okay, so whenever you put a request to create a particular pod, that request goes to the kube api, and kube api pass this informations to the scheduler, and scheduler find that particular node and provide these informations to the kube api. Kube api put all the entry into etcd data store and pass this all informations to the kubelet, and kubelet is responsible to pass this informations to the container tools. So whatever you have, either you have the Docker, either you have a containerd, or you have the Rocket. So in this way the things works, and all the informations passed by the kube api to the kubelet. So kubelet pass all this information to the container to create a node, create a pod in a particular node. So node is a worker machine in Kubernetes where we do all the deployments. So a pod always run on a node. That is you already aware about. The pod will always run on the node, and that node will be the worker node. Okay, in some scenario you can deploy the pod into the master node also, but in that case you have to check there should not be a tent applied to the master node. Or you can put the tolerations things, you can club it into the pod definitions file so that it can meet the tolerations features. That I will discuss the thing and toleration in the next sessions. But this is the worst scenario, because we master node is not a things that can be used or not recommended to use for the deployment of the pod. You need to have the deploy the pod in the worker node only. So that's why we applied that change. So unfortunately, or due to some mishappening, none of the pod get deployed by mistake in the master nodes. So this is the pod definitions file. You can say that the pod definitions file use the version VI. The API version is VI. The all the things will be properly intended. So you need to look into this aspect very carefully. Otherwise, the applications will provide you an error. So the kind, the P will be capital. Pod, and beside this the metadata which keeps this is the dictionary kinds of thing, you can say. So you put the name, this is the name of the pod, a static web in my example. You can provide the labels, and labels as per your requirement, whatever you required. You want to put some environment informations like env space productions or development environment, or something like about, you can put some information regarding the database is not so big or small, so that you can deploy it accordingly, or you can fetch the informations accordingly on this. So the specification part, this is the most important because it's creating the container. So you can do the multiple container also, because it's a list or array kind of thing. So you just need to provide what is the name of your container. So inside the pod you are creating a container using the image. So in this particular example, I pass the image as nginx. So it's coming from the Docker Hub. So system or the applications will understand, okay, the user is passing the nginx, so we need to fetch from the Docker Hub, which is the public repository for keeping the image, or you can provide the informations from the private registry also. So this is the pod definitions file in the YAML format, how you can deploy it. So this is the declarative way, but in the exam perspective for the CKA or CKAD, you should have to do in an imperative way by running the command, so it will save the time also. Or I will demonstrate you in the lab session how can we generate the definitions file by using the command, so that you don't have any error in the YAML definition file. So when we create a pod or the YAML definitions file, you just need to run a kubectl space apply space hyphen dash f for the file and the definitions file, and when you press the enter, the pod will get created. But the pod will get created in the default namespace. The namespace related sessions, I will create another video for that. But for the time being, you just need to understand there are some namespaces, and we are not defining any namespace thing in the definitions file, so it will create into a default namespace. So once the pod it gets created, how to get the informations? So you need to run the kubectl get pod. It will list all the pods that created in a default namespace. So in the right side, you can see there is a table. If you create a pod, you need to have the you need to use the revision v1 for the service v1 for the replica sets, which is going to my next session, in which you can use the apps v1. So this is the version things, and you have to do it in a similar way, because otherwise the applications will produce you an error. So the deployment for the same as the replica sets. So this is some command that I gathered here. Suppose you want to see the details of the pod that created just now. So you need to run kubectl describe pod with the pod name. In my case, it's a static there. So details of pod with wide options. So wide options will tell you some extra informations, like in which particular nodes the pod get deployed, details of the pod with the label. Okay, if you see the previous screen, here we are providing the role is equal to role colon my role. So this is the label, and if I have hundreds of pod in a particular environment, how we can fetch by using the labels. So the labels is very important things. If suppose we want to get all the ports detail in a list which is related to the production, so in this way, suppose you need to run the command kubectl get port minus dash l, that is used for the selector, and here you need to provide the label role is equal to my role. So it will get all the ports that have this level, at least this level. So you may have the multiple levels as per your need, so at least these labels will be available in the ports in which you are fetching the information. So this is very helpful when you are just filtering the ports on the basis of role criteria. The image, which image that you can get the image from the describing the pod also, or if you want to get a specific only the image informations, you can use the grep command also. With the dash I, it will provide you the image informations that use in the pod while creating the pod in a particular nodes. So this is the theoretical aspects, but the lab which will provide you all the informations regarding how to create a pod by using the definitions file, how to create a pod using the imperative way by running the command. So I will demonstrate all these things in the lab. And if you like my video, please subscribe my channel and click on the bell icon so that you can get the latest notifications on my on my videos that I am going to upload in future. So thanks for watching this theoretical part, and now we are going jumping to the lab session. Okay, let's monitor the environment first. Qctl get pod. So currently we don't have any pod in the running in the environment. So for the imperative way, I will run first a command to create a pod. Kubectl run. The name of the pod is simple pod. Image that I am going to use is Nginx, and just press the enter button. So the simple pod is get created. Let's monitor it by running kubectl get pod. So this is the simple pod that is currently running. So how we can describe this pod? How we can see the details features of this pod? What the image is used? What is the container name? All the things. Kubectl describe. Name of the pod. And here you will find all the informations like which image is used in this particular pod creations, and what is the label which get default assigns when we use the imperative command, and this is the internal IP of the pod. So let's clear the screen. And if I want to fetch the image name, how we can do that? Kubectl describe pod. The pod name is simple pod, and grep for the image. So this will show you which image we are using to create a pod, which container will be running in a pod. It is of image Nginx image. So let's do one more thing. Kubectl get pod O of wide. So it will give you some other fields as well, like this particular pod which name is simple pod. It's running one container out of one container, means this pod have a single container which is in running state. It's not restarted yet anytime, so there is no crash. The age is 110 seconds. This is the IP, and in which node it's running on the control plane node. So these all things you can find by running the wide command. Okay, so now let's do it in the same thing in a declarative way. So let's generate the definition file by running the command as well. Kubectl run simple pod say 1 using the same image Nginx try run is equal to client O of YAML. So this will give you the definitions of the pod. You don't have to create it. So copy it till this point. Control C or copy. So let's open the Vim editor pod.yaml and paste it here. And you can modify the things accordingly. Like this command, this thing I don't require, so I delete it, and the pod name, suppose I want the labels to should be like environment. So you can do whatever level you want. What is your requirement? So I'm creating this pod for the development environment. So let's say dev. dev. So I generating this definition file by using the command, but I am editing it for simplicity. So save it. Now I'm going to apply it. kubectl -f, no sorry, apply, then the file name, and file name is pod.yaml. Okay, so this get applied, and if you see the how many pod you have currently, get pod. So this will open give you the details of whatever the pod is running. So this is the pod that I created just now by using the definitions file, simple pod 1. So let's clear the screen. kubectl get pod using the selector. What is the select? We have environment is equal to env is equal to prod or development. I forgot it. I think development. So okay, so I am using the selector and I am fetching the result of the pod by using the selector that I used in the label environment is equal to dev. So in this way you can create it, but there is one disadvantage that if I delete the pod it will not come back. Let's see. kubectl get pod, and let's delete one pod. kubectl delete pod, simple pod. Okay, let's delete it. So I'm currently deleting one pod that I created by using the command, and it will not come back. So this is the disadvantage. That's why in the next session we are going to learn about the replica sets. So how the replica sets run on the top of the pod, and it will managing all the desired pods to be running all the time. So whatever the desired pod, if I be required the 3 pods to be running all the time, so all three it will maintain that particular number. So always you will find that the pod get destroyed for any reason, but it will create it again. So this is the advantage of replica sets, and after that we will have a session on deployment. So in deployment have the very rich advantage, and we will see in the next session. So if you like my video, just subscribe to my channel and share it with your friends as well. Thank you for watching my video.